So today we're going to talk about direct variation, and direct variation is something that we've kind of worked with before when we've dealt with some proportions. And so the definition of direct variation is the equation y equals k times x, where k is some number. So k could be negative, k could be positive, but k cannot be 0. Okay? So we actually call k a special name. K, we call that the constant of variation. Constant, remember, a variation can be negative, it can be positive, but it can't be 0. Right. Okay? We also call the constant of variation the constant of proportionality, because if you remember, I said direct variation is similar to proportions. And the constant of variation is also known as the slope. And we've just learned about slope. Okay? So, the constant of variation is also known as the constant of proportionality. It's also known as the slope. So now what we're going to do is we're going to go ahead and look at an example on the next slide. And we're going to go ahead and complete the following. So let's go ahead and look. Name the constant of variation for the equation. So if I look at the equation, what is the equation?
Y equals 1/2 x.
For those of you that haven't seen where the equation is, let's try and get that a little bit lighter. Oh, boy, we're skipping. There we go. Here is the equation here, y equals 1/2 x. Okay. Now it says to find the slope of the line that passes through these pair of points. So first of all, the constant of variation in there is what? 1/2. Good. Basically, the constant of variation is nothing more than the number in front of the x. Okay, because this is y equals k times x. So the constant of variation, k, equals 1/2. Now, it wants you to name the slope of going through each pair of points. Well, here's two pair of points here, or a pair of points, sorry. The slope, remember, is rise over run. So what's the rise between these two? 3. The run is 6. So the slope here would be 3 divided by 6, which is 1/2. But that should make sense because what did I tell you on the first slide?
The k also will equal the slope.
The k is the slope. Okay, so it really should be the same, but we really wouldn't even need to go through finding the slope because we already know that the constant of proportionality is the slope. So here you go. Name the constant of variation. Okay, so name the constant of variation for y equals -2x. Name the constant of variation for y equals -2x.
Or that looks. Okay.
We have some variation, just like we did on the problem before. Okay, shouldn't take us very long. Just go ahead and take a guess. Just take a guess.
Is there a question mark?
All right, so let's see what you got. Name the constant of variation, and the constant of variation is -2. Nice job. Remember, the constant of variation is nothing more than that number. That's it. Now, what would the slope of this be? -2. Okay? All right, so let's go ahead and look at this. It says graph y equals 3x. So now what we're going to do is we're actually going to plot some points. Now, I will tell you that in a direct variation equation, you will always start, if it's in this form, if it looks like this, y equals something times x, you will always start at 0, 0. What's the slope of that line?
3.
Slope of that line is 3. So what that means is that I'm going to go up 3, and then I'm going to go over 1, because another way to write 3 is 3 over 1. So what I'm going to do from 0, 0 is I'm going to go up 3 over 1. From this point, where can I go? Up 3 over 1. And there is the line that you can draw in. Okay, so all we would need to do there is we would need to go ahead and draw a line through those points.
How many lines do you have to draw?
1,
No, they got, how many points do you have to draw in, like,
3.
on our homework? 3?
3. 3 is always a good rule of thumb. So let's look at the next one. Okay, the next one, if I look at here, this one says y equals negative 2/3 x. This is in the form y equals something times x, so where do I start?
0.
0, 0. Now, when it says negative 2/3, what does that mean?
Go over to the left.
I go what?
To the left. To the left.
So my slope is,
Negative 2.
just hold on real quick, hold on. Slope is negative 2/3. So negative 2 refers to the rise. What does 3 refer to?
Run.
The run. So when it says a rise of negative 2, what that means is that you actually go down 2. A run of 3 means that you do what? Go over 3. So from this point, where am I going to go? Down 2, over 3. And so now what I'm going to go ahead and do is draw the line through those points. Okay, and there you go. Okay, so that's the second part of your homework. Okay, so real quick, let's review. When you have a graph of direct variation in the form y equals kx, where k cannot equal 0, okay, they will always pass through the origin. That's the one thing to file away. They're always going to pass through the origin. So on your test, quiz, whatever, if you have a dot there, you're at least going to get partial credit. So remember, with a graph of direct variation, they will always pass through the origin. And we'll talk more about graphing when we look at some more problems there. We'll even get the netbooks out probably too. So let's go ahead and look at this one. It says the graph illustrates which type of slope. So if I look at that graph right there, what type of slope is that going to be? If I look at that, is it going to be a positive, negative, or a constant? So positive slope, negative slope, constant. Let's see what we got. The answer is negative. Okay, good job. So the slope, or the graph actually goes down, so it's negative. Let's look at this one. What type of slope do we have here? Okay, no, that's fine. So the slope here is positive because the graph goes up. So that was kind of a little bit of a review about slope. Remember, negative slope goes down, positive slope goes up. What does a constant slope do? Yep, side to side. It's a horizontal line. Good job. Okay, so now let's look at this next problem. It says, suppose y varies directly as x. So whenever you see, oh shoot, let me do this one. There we go. Whenever you see this statement right here, that means y equals k times x. So whenever they tell you that, that means y equals k times x. And then they tell you that y equals 72 when x equals 8. Write a direct variation equation that relates x and y. Use the equation to find x when y equals 63. First things first, y varies directly as x gives us that equation. Next thing, we're going to deal with this. Y equals 72, so I'm going to put 72 in for y, and I'm going to put 8 in for x. So I'm just going to kind of walk through this step by step. So I've got k times 8. So what do you think I'm going to do now? Divide by 8. And so you end up getting 9 to equal k. So now what does that tell me? That tells me that this number right here is 9. So really my equation becomes y equals 9 times x. So there you go. That's your first answer. That is the direct variation equation. Use the equation to find x when y equals 63. So what do you think I'm going to do now?
Plug in 63 for y.
Plug in 63 for y.
Equals 9,
And then so
divide by
now what I
9.
do to solve is divide both sides by 9. And so I get x to equal
7.
7. So that's your second answer. Okay, so your equation is first and x equals 7 is your second. So now what I want you to do now is I want you to do the same thing here. Okay, suppose y varies directly as x and y equals 98 when x equals 14. Write a direct variation equation that relates x and y. Use the equation to find y when x equals -4. On your expression, you're going to enter the answer in to this very last statement. So on your expression, you're going to enter in that very last answer.
The calculator's still on.
Yep.
Drop my calculator today. Oh,
14.
I didn't see that.
So then now find y when x equals -4. So y equals. Yep. When x equals -4. Okay, we've got a few more finishing up. And then we'll go ahead and look at.
What's your birthday?
It's my birthday too.
No, it's happened already.
4 months.
Okay, let's see what we got. We got
Yeah,
x equals -28. Nice job. So real quick, what you should have done, remember, whenever you see y varies directly as x, that's where you start. Next thing you should have started is by plugging 98 in for y, and then 14 in for x. When you solve that, you end up getting k to equal 7. So your new equation is y equals 7 times x. Now this one was a little different than the page before, because the page before you were finding x. In this case, you're finding y. So all you needed to do here is take 7 times -4, and you come up with -28. Okay? All right, so let's go ahead and look at what we have here. The very last thing we're going to do is we're going to talk about, okay, another direct variation type of equation, and that's the distance formula. Distance equals rate times time, and that should make sense. Because if you go 50 miles an hour and you drive for 1 hour, you will go 50 miles. Okay? And so if you look at this, it says the distance a jet travels varies directly as the number of hours it flies. So basically they're telling you that the jet fits this equation right here. So a jet traveled 3,420 miles in 6 hours. So distance equals rate times time. D equals R times T. Distance is 3,420. Rate, we don't know, but we do know that the time is 6. So how can I find the rate?
Divide both
Yeah,
sides.
divide both sides by 6. And what do you get the rate to be?
570.
570.
570 miles per hour. Now, what they do is they want you to write a direct variation equation. So what I'm going to do now is write this as D equals 570 times T. That's the direct variation equation. Very last problem, estimate how many hours it will take to fly 6,500 miles. So what you're going to do is use the answer you found first, now in the second. So 6,500, will that go in place of D or in place of T?
D.
D. So 6,500 equals 570 times T. How do you solve that?
Divide.
Divide by 570. And how many hours does it come out to be?
11.40.
11.40. So they said estimate how many hours, so roughly you're looking at about 11 hours. It probably is a little more than 11 hours. Okay, but since this says estimate, we're not looking for an exact answer, so that's why we need to answer 11. Okay, think you can handle that?
Maybe.
Your assignment for tomorrow, pages 185 through 186. 10 through 26, the evens, 30, 32, and 34 through 37. And just a little bit, this 34 through 37 is all on the 34 through 37. 10 through 26, the evens, 30, 32, 34 through 37.